There are things happening in space that scientists have measured, confirmed, and documented, and then quietly stopped talking about. Not because the data was wrong, because the data was right, and it didn't fit anything they could explain. These are not conspiracy theories. These are peer-reviewed observations sitting in scientific journals, unresolved, collecting dust while the rest of science moves forward and pretends they don't exist. Here are 20 space facts that scientists are still afraid to explain. Number 1. The Great Attractor. Something is pulling us. The Milky Way, Andromeda, thousands of galaxies, all of them moving toward the same point in space at 22 million kilometers per hour. We can measure the pull. We can calculate the direction. We cannot see what's causing it, but you see, because it's hidden behind the Milky Way itself. Scientists named it the Great Attractor in 1973. Decades later, the explanation is still incomplete. Something massive is out there. We are moving toward it. We don't know what it is. Number 2, the WOW signal. August 15th, 1977. A radio telescope in Ohio picks up a signal, 72 seconds long, perfectly structured, coming from deep space. The scientist reviewing the data circled it and wrote one word in the margin: wow. The signal was so strong, so precise, so unlike anything natural that it matched almost exactly what scientists said an alien transmission would look like. It never repeated. It was never explained. 47 years later, we still don't know what sent it. Number 3. We shouldn't be here. This one is not philosophical, it's physics. When the universe began, equal amounts of matter and antimatter were created. When matter and antimatter meet, they destroy each other completely. If the Big Bang produced equal amounts of both, everything should have annihilated. No stars, no planets, no us. Something tipped the scale by 1 part in a billion in favor of matter. Without that imbalance, nothing exists. Scientists have no explanation for why it happened. Number 4. Dark energy. 68% of the universe is made of something we cannot see, cannot detect, and cannot explain. We call it dark energy. But that name is just an admission that we don't know what it is. We know it exists because without it, the expansion of the universe wouldn't behave the way it does. We know it's real. We know it's everywhere. We know it's the dominant force in the universe, and we know almost nothing else about it. Number 5. The black hole at the center of our galaxy just woke up. Sagittarius A star, 4 million solar masses, sitting 26,000 light-years from Earth at the center of the Milky Way. For decades, it was relatively quiet. Then it started consuming matter unpredictably, flaring, brightening. In 2019, it became 75 times brighter than normal in a single night. Scientists are watching it closely. They are not sure what triggered it. They are not sure what comes next. Number 6. Neutron stars break physics. When a massive star dies, its core collapses. Electrons and protons are crushed together into neutrons. What's left is a ball roughly 20 kilometers wide, but with a mass of 2 suns. A teaspoon of neutron star material would weigh 1 billion tons on Earth. Inside a neutron star, matter behaves in ways our current physics cannot fully describe. The equations break down. The models don't hold. We know they exist. We don't fully understand what's inside them. Number 7. The universe is expanding at two different speeds. There are two ways to measure how fast the universe is expanding. Scientists have spent decades perfecting both methods. The problem is they give different answers, not slightly different. Different enough that one of them has to be wrong. Or our entire model of the universe is missing something fundamental. This is called the Hubble Tension. It has no solution. Every year, the measurements get more precise. Every year, the disagreement gets worse. Number 8, ghost planets. Not every planet orbits a star. Some were ejected from their solar systems billions of years ago. They drift alone through interstellar space. No heat, no light, no orbit. Current estimates suggest there may be more rogue planets in the Milky Way than there are stars. Billions of dark, frozen worlds wandering the galaxy in complete silence. We have confirmed several. We suspect there are many more. Number 9, the silence. If the universe contains hundreds of billions of galaxies, each with hundreds of billions of stars, and a significant fraction of those stars have planets in habitable zones, where is everyone? We have been searching for signals for decades. We have found nothing. The universe is 13.8 billion years old. There has been enough time for civilizations to rise, expand, and fill the galaxy many times over. The silence is not absence of evidence. It is a fact that demands an explanation we don't have. Number 10. The moon is too perfect. The moon is 400 times smaller than the sun. The moon is 400 times closer to Earth than the sun. This is why, from Earth, they appear exactly the same size in the sky. It's why total solar eclipses are possible. The moon fits perfectly over the sun, covering it completely. The mathematical probability of this being a coincidence is extraordinarily small. No other planet in our solar system has a moon that does this. Scientists don't have a satisfying explanation for why our moon happens to be at exactly this size and distance. Number 11, dark matter. 27% of the universe is dark matter, invisible, undetectable directly, but its gravitational effects are measurable and real. We have built detectors deep underground to catch it. We have searched for decades. Nothing. Without dark matter, galaxies would fly apart. Stars at the edges of galaxies move too fast. The math only works if something invisible is holding everything together. We know it's there. We cannot find it. Number 12. The universe has a perfect temperature, the background temperature of the universe. The faint glow left over from the Big Bang is 2.725 Kelvin in every direction. Not approximately, not roughly, precisely, uniformly, everywhere. For the universe to be this uniform after 13.8 billion years of expansion, regions that are billions of light years apart and have never been in contact with each other would have to have reached the same temperature. That should be impossible. The explanation, cosmic inflation, is widely accepted but never directly proven. Number 13. The first image of a black hole revealed something unexpected. In 2019, we photographed a black hole for the first time. M87 star, 6.5 billion solar masses. The image matched theoretical predictions. That was the headline. What didn't make the headline? The image showed asymmetries. The bottom of the ring was brighter than the top. More than expected. suggesting the jets of energy being released were not behaving exactly as our models predicted. Scientists are still debating what this means. Number 14. Quasars release more energy than we can explain. The brightest objects in the universe are quasars, active galactic nuclei powered by supermassive black holes. In 1 second, a quasar can release more energy than our sun produces in a million years. The mechanism by which matter falling into a black hole can produce this level of energy output is still not fully understood. Our models account for most of it. Not all of it. Our models account for most of it. Not all of it. Number 15. The universe is flat. That's a problem. Measurements show the universe is geometrically flat to within 0.4% precision. For the universe to be this flat, conditions at the moment of the Big Bang would have had to be tuned to extraordinary precision. If the initial density had been off by even 1 part in 10 to the 60th power, the universe would have either collapsed immediately or expanded too fast for anything to form. The proposed solution is inflation. The evidence for inflation is indirect. Number 16. Fast radio bursts. Millisecond flashes of radio energy from deep space. In a fraction of a second, they release more energy than the sun produces in days. Some repeat. Most don't. The cause of most of them is still unknown. Several sources have been identified. The mechanism behind the energy release is still debated. Every year, we detect more. Every year, the mystery deepens. Number 17. Something might be breathing on Titan. Saturn's moon. Titan has lakes, rivers, rain, and weather, all made of liquid methane instead of water. Chemical models of Titan's atmosphere predict a certain level of hydrogen near the surface. Measurements show less hydrogen than predicted near the surface, as if something is consuming it. On Earth, that pattern would suggest metabolism, life-consuming hydrogen, the way we breathe oxygen. Scientists are careful with their words. They call it anomalous. They say more study is needed. Number 18. Enceladus has everything life needs. Saturn's other famous moon has a global ocean beneath its icy surface. The Cassini spacecraft flew through its geysers and found water, organic molecules, heat, and phosphorus, every known ingredient for life as we understand it. Phosphorus was the last piece. When it was confirmed in 2023, scientists went quiet for a moment. Everything is there. Whether anything is using it, we don't know. Number 19. Some stars are older than the universe. Our best measurement of the age of the universe is 13.8 billion years. Certain stars, called Methuselah stars, have been calculated to be older than that. One in particular, HD 140283, has an estimated age of 14.5 billion years, plus or minus 800 million years. So it might be younger than the universe, or it might not be. The error bars allow for it, but barely. If the measurement is right, something is wrong with our model of the universe. Number 20. Observation changes reality. In quantum mechanics, particles exist in multiple states simultaneously until they are observed. The act of measurement collapses the particle into a single state. This has been confirmed in thousands of experiments. It is not theoretical. It is observed, reproducible, real. What it means, whether the universe requires a conscious observer to exist in a definite state, is something physicists argue about and mostly avoid in public, because the implications are too large, because it raises questions that science does not yet have the tools to answer. The universe is not a solved problem. It is a place full of confirmed measurements that point toward things we are not ready to understand. The data is real. The silence around it is a choice, and the more carefully you look, the stranger it gets. If this changed how you see space, share it with someone who needs to look up more often. Subscribe, because we are just getting started.